The basic form of exponential functions is y equals a times b to the x, where a and b are constants. Does that look similar at all to what we did yesterday? The basic form, right? Okay. What effects do a and b have in the tables representing the functions below? Find out by using a calculator to complete each table. So I need 6 tables completed. I'm going to zoom out a little bit so you can see them all. I need 6 tables completed. So who's got 1? 1. Who's got 2? You guys 3, 4. You guys 5 and 6. What do you guys have? 4. You guys have 4, so I need 5 and 6 still. Who's doing 5 and who's doing 6? They got 2. 5? Okay, who's doing 6? Anybody? Nobody's doing 6? You guys got 6? Okay. As soon as you get them filled out, all I want you filling out right now is this table part. I don't want you filling out this. I don't want you to fill out this for right now. Only the table part. Okay? As soon as you get it filled out, if you did not volunteer to do one, you need to still be doing one at your desk with your calculator. Okay? Let me be clear on something so there's no misunderstandings. Everybody listen, please. This says what? 3 times 2 to the x power. I just didn't want any confusion because some people earlier thought it said 3.2. And that'll give us a completely different answer. Okay? 3 times 2, 2 times 3, and so on. Okay? As soon as you get it filled in, come back here and fill it in on the projector. You can choose any color you like. I have even these. Good job. You can choose any color. It's your choice. I even have these right here if you want to choose these instead. You get to choose. You get to choose. I got new pens, so yeah, they were present. My friend Madeline. Yeah. All right, I need 5 and 6. I'm going to scoot it up just a little bit. There you go. Good job. You get to choose any color you want. I even have these right here if you'd rather have one of these. Thank you. Good job. All right, you ready? Let's talk about this. If our main function, I'm going to zoom in just a little bit to make it a little bit easier to see. If our main function is y equals a times b to the x, and it tells you y equals 3 times 2 to the x, can you identify a and b right off the bat? Yes? What is a? 3. And what is b? 2. Okay, what about in number 2? What's a? 2. And what is b? And how do you know for sure which one's which? How do you know for sure which one's which? B has a power, right? B has the exponent with it. A is a multiplier in front and B has the exponent with it, right? So what about number 3? Okay, well, B is 6. That's pretty obvious, but what's A? How do you know it's 1? Nothing's there, and the only thing you can multiply by something to not change its value is 1, right? Okay, what about number 4? A is 8, B is 0.5. Number 5, A is 100, B is, and on number 6, A is 200, and B is 0.8. Okay? Look at the questions on the side. Where does the A value show up in the table? So where x equals 0 every time? Looks like, so for these 6, for sure, anytime x is 0, that's where A shows up in the table, right? So for sure these 6, but now I'm asking every time? What's going to happen if I put in a 0 for x? What's anything to the 0 power? 1, and 1 times the A value is always going to be the A value, right? So I'm going to ask it one more time. Every time? Yes. Okay, and now we know that with confidence, right? Okay, let's look back here at the ratio. Okay, what is a ratio to begin with? A fraction, right? That's exactly right. It's a fraction. When we're trying to find the ratio in a table like this, an exponential table, I take any value in the table and divide by the value before it. Okay, so 6 divided by 3. 2. 12 divided by 6. 2. 24 divided by 12. 2. 48 divided by 24. Okay, that's interesting. Look at number 2. 6 divided by 2. 3. 18 divided by 6. 3. 54 divided by 18. You didn't seem as confident about that one. Oh, you can't do that one in your head? Okay, but you have a calculator to check, right? Okay. So now you're confident about it, right? 162 divided by 54? 3. What about number 3? 6 divided by 1. Hopefully you didn't have to use your calculator for that one, right? 36 divided by 6. 216 divided by 36? 1296 divided by 216. 6. Some of you, I saw some of you check it. Some of you, are you just assuming? Or did you just happen to know that 1296 divided by 216 is 6? I mean, some people might. I'm not judging you. 4 divided by 8. Half. 2 divided by 4. Half. 1 divided by 2. 1 half. 0.5 divided by 1. Half. 50 divided by 100. 25 divided by 50. 12.5 divided by 25. 6.25 divided by 12.5. Half. 160 divided by 200. Now, your calculator is going to be a jerk to you on this one, isn't it? If you put in 160 divided by 200 and hit enter, what does it tell you? 4 over 5. Okay. Should we write 4 over 5 or should we write 0.8? Okay. Does it matter? No. What's 128 divided by 160? 4 over 5. Okay. 102.4 divided by 128. So that one says 0.8, doesn't it? Okay. And then 81.92 divided by 102.4? 0.8. Now, we are smart enough to know, or we're smart enough to use our calculator to figure out that these all mean the same thing, right? Hopefully you know that without having to use your calculator, but they all mean the same, right? Okay. So the question then on the side says, what effect does the B value have on the table? It's the ratio. Okay. Now, the only quote-unquote trouble people have sometimes is that what we wrote down for our ratio is not what it says in the equation. Well, we're for sure not going to panic about that one, right? Because we can tell easily that 0.5 and 1/2 are the same. This is the kind of thing where sometimes it comes into play. You're not going to panic about it. If you don't know these things off the top of your head, you're going to check them with the calculator, aren't you? Okay? For functions in the form y equals a times b to the x, a is the. Well, there's some vocabulary terms that I need to make sure that you understand so that not only this will make sense, but this other stuff over here, though, like word problems, make sense. You okay with that? A is the initial amount. Or the starting amount. What else is A? What did we decide a second ago it was? It's where x equals 0. What's it called on a graph where x equals 0? It is the y-intercept. I'll go and apologize now for writing outside of the box. I hope you can get over it. So what's B? It's the ratio, first of all. I'm also going to write in parentheses what you multiply by. And I don't want you to be confused by that. How do we find the ratio here? I divided, right? So why am I saying it's what you multiply by then? So if we're going down the table, 8 to 4 to 2 to 1 to 0.5, it's what I'm multiplying by to go down the table, right? When I actually find the ratio, what do? I go up the table, dividing, don't I? Are you okay with that? What else is B? What does B literally stand for? The base of the exponent. Look back at our tables real quick, please. When are the y values increasing? When what is greater than 1? When the base is greater than 1? So can I say when b is greater than 1? And when are the y values decreasing? When b is less than 1? Oh, okay. That seems familiar. Does it seem familiar to you? Why does it seem familiar? What's it called when b is greater than 1? Uh-huh. And what's it called when b is between 0 and 1? Mm-hmm. Good. Any questions about any of that? Someone asked me a question that they think someone else might not understand about the vocabulary, about the information I just gave you. What might be confusing? What do you think people get most confused about? Typically these. Okay? Typically these. Remembering that y values are increasing when b is greater than 1, and y values are decreasing when b is between 0 and 1. Sometimes they forget, they get these switched, whether which one's called decay or which one's growth. You okay? But not you guys. You guys understand that, right? Okay. Can you go backwards? If I give you the table, can you give me the equation and the ratio and a and b? Okay. I have 4 tables here that need to be filled in. Only the equation. Well, no, we can do all of it. The equation, the ratio, and a and b. So if you didn't volunteer before, go ahead and volunteer now. And get back here and fill in a table. Who's got 7? Okay, who's got 8, 9, and 10? Who's got 10? Okay, thank you, Tanner. Get them filled out and come back here and fill them in. Oh, I'm zooming the wrong way. Here you go. In a minute. Remember, if you did not volunteer to do one, you need to be doing one by yourself, and then you can check it by looking at the screen. Guys, I don't care if you write your ratios as fractions or decimals. Either one is fine with me, as long as they are correct. You can choose any color. Yep. No, that's fine. That's how you did it, so that's what I want. Check your answers with these, because these are all correct. Anyone write theirs differently? Any of them? You wrote them exactly the same way that are on the board? You did decimals instead, so what did you write here? So 1.5? Okay, what about here? Okay, good. Those are right. Hard or easy? Okay. Look about these real quick. These ones on the side. We're not going to use a calculator. We're going to use our brain. I know. You'll be fine. What if x is 0? Let me zoom in a little bit. 4 times 1 to the 0 power. Well, what's 1 to the 0 power? What's anything to the 0 power? 1 times 4? Okay, what's 1 to the first power? Times 4? 1 to the second power? 1 times 4? 1 to the third power? Times 4? What if b was a negative number? Okay, negative 2 to the 0 power, 1 times 4. Okay, negative 2 to the first power, negative 2 times 4, negative 8. Negative 2 squared, 4 times 4, 16. Negative 2 to the third power. So negative 8 times 4, negative 32. Look at this real quick. Control T, go away table, tab. I want to show you this graph. Well, what's the first one look like? Do I need to graph that for you? No matter what x is, y is 4. It's a line, right? It's a horizontal line, in fact, isn't it? That's not exponential, is it? But I have my variable and my exponent. 4 times negative 2 raised to the x power. Why do you think we usually don't use these values for b? Because I didn't let it graph all the way. Here's what it looks like when it's graphed all the way. That's definitely weird, isn't it? Okay. Yeah, it's a barcode. If you scan it with a barcode reader, it gives you the meaning of life. Not really. I'm just teasing. Just teasing. I'm sorry. I didn't mean to tease you. Because they're weird. Okay? All right. I'm going to do one of these for you, and you're going to do the other one. Is it all right if I do the top one? And you guys are going to do the bottom one for homework. Okay? They're similar, but not exactly the same, so you're going to have to think. Okay? To help out with the cost of tuition, room, and board, you take out a loan for $20,000 for college. You do not have to make any payments on the loan until you leave school. However, the loan amount accumulates interest at the rate of 12% annually. To determine how much you will owe after X years of school, complete the table and the graph. Round the answers to the nearest whole dollar. We don't want to be dealing with pennies here. Okay? Nearest whole dollar is what we're going for. Everybody understand so far? Table, graph, equation. Which one do you want to do first? How are you going to fill in the table? Oh, equation? Okay. So remember, we want our equation to look like y equals a times b to the x. Can I make some like commercial type comments about this problem real quick? Okay, number one, I know maybe you're not going to go to college. Maybe a trade school is the more thing that's better for you. I support that. Okay? This just happens to be the example we're doing today. Are you okay with that? Number two, if you're going to go to college, please, please, please find a better percentage rate than 12%. Please. This is really high. Okay? Maybe try to find 3 or 4 if you can. 5. But the lower the better, right? Okay? I think that's all the commercials for now. So back to the show. You ready? Here's our general form that we want filled in. Do you remember what the vocabulary things that we filled in on the back of this sheet, what A and B stand for? Then do you know either one of those? A is 20,000 because we called that the starting amount or the initial amount, right? That's what I started with. Another way to know that A is 20,000 is x equals 0 in the table, right? Well, you always have a table. No, so it's good to know that we're starting. You can read the words. We're starting with 20,000. Are we increasing our amount from here or are we decreasing our amount from here? Increasing, so that's going to affect our B value. Okay? What do you think our B value might have something to do with? With the 12%, right? Okay? But since we're increasing in value with our B, what do you think our B actually is? 1.12%. Why is it 1.12%? Can I give you a clue by telling you the answer? If I'm going to figure out how much I owe after 1 year of school, I would have to take the 20,000 and multiply it by 0.12. What is that going to give me? That's going to give me my interest that I owe, right? Which will be 2,400, I think. And then to find out how much total I owe, what do I have to do to that 2,400? I have to add it to the 20,000 that I originally borrowed, right? 22,400. If I do the 1.12, that takes that into account. That is part of the equation already. It's like I'm saving myself a step by multiplying by 1.12. Okay? So that's what's happening if I'm increasing in my amounts. Like I'm owing more and more and more because I'm not paying anything on it because I'm still in school, right? What happens if I was paying off something or something was decreasing in value? What would I do to find this B value? I would subtract it from 1, wouldn't I? Because wouldn't I have to find out the interest and subtract it from the original amount to begin with? So let's pretend we're not, but we're pretending that this is decreasing. What would this value be here? 0.88 to the x if I was decreasing. Because I say 1 minus that interest rate. 1 minus that percentage rate. Does that make sense? So I'm increasing in value. My table is going to be increasing because I'm not paying anything off. I've just borrowed this money and I'm still going to school. And so I say 1 plus 0.12. So 1.12. Does that make sense or no? Yes? Now can I fill out the table and the graph pretty easily? Yes? So you can either just do this one at a time or you can put this into your calculator and look at the table, correct? What do you get when you do that? $22,400. What's next? $25,088. What's next? 28,000. So 99. Because remember we're rounding to the nearest whole dollar. You okay with that? What about 4? So 470. 31,470. And then 5. 247. Okay, 35,247. 39,477. Are we agreed or no? Yes? That sure looks like a lot like a line. Is it a line? That's not a line, is it? At first when you look at it, it looks like a line, but it's a curve, isn't it? Okay. Do we expect a curve? Because exponents are curves, right? Okay. Guys, supposing after graduating college you decide to enter law school. So that means you're going to go to school for 4 more years after college, right? So how much are you going to owe after 8 years of school? Well, we could look at our table, or we could say 20,000 times 1.12 to the 8th power. And what do you get when you do that? Out loud. $49,519. Suppose after graduation, instead of going to law school, you decide to go to medical school. So you're going to go to school for 8 more years after your original 4. How much would you now owe after 12 years of school? $77,000. What'd you say? 919 or 920? 20? Okay. What's the domain and range of this problem situation? So time out. Think back to yesterday. What was the domain and range of our parent function? What's the domain? All real. What's the range? Y is going to be greater than 0. Does it ever get to 0? Is it y is greater than or equal to 0? No, it never gets to 0, does it? Okay? So that's our parent function. What's our problem situation domain and range, though? In this problem situation, what are our x values allowed to be? Look at our x values, either on the table or on the graph. X is going to be greater than or equal to 0. Because I can have 0 years in school, can't I? I can't have -1 year in school, can I? What about my range? Perfect. Y is going to be greater than or equal to 20,000. Yeah, that's where it starts out, right? That's my initial amount, and my y value is increasing, right? Okay. Any questions? So what are you going to do for homework? The second one? We have a couple minutes. Do you want me to make sure that your equation is right before you get started? Okay, so as a graduation gift, your grandparents buy you a shiny new car worth $20,000. However, due to wear and tear, the car loses 20% of its value every year. To determine the value of the car after X years, complete the table in the graph, round the answers to the nearest whole dollar. So once again, y equals a times b to the x power. What do you know? A is 20,000 times b, y. We are losing 20% every year, so our b value is going to be very good. 1 minus 0.2, which would be 0.8. Okay? Any questions about that? So that'll give you a good starting point to find your table, your graph, and answer the questions at the bottom. Got it?